So the nice thing about some of these transformation objects that we're going to take a look at are that they mimic functionality that in Rhino that is really useful, such as flow along curve. And that's what the curve array object is going to allow us to do. But also, as we start to move into things like polar and rectangular arrays, it's going to automate our process very significantly, so that instead of having to build up a series of transformations using like incremental moves, etc., to transform or array a series of objects in space, we can use these pre-built objects. And even more so, we can use more complex or transformations that combine individual transformations, such as the Kaleidoscope. So it's kind of a compound transformation to create some additional kind of complexity within the collection of elements that we're distributing. And then we can take one of the relatively new objects called rectangle mapping, and if we were to, say, first distribute a series of rectangles, we could then apply a particular type of geometry into each one of those rectangles. So let's take a look at the objects that we just highlighted in Grasshopper that allow us to array and map geometry using transformations. All right, so the first one that we want to do is let's take a look at the objects that kind of mimic some of the transformations that you can find in Rhino's functionality under the array options under the transform menu. So if we go to transform array in Grasshopper, we're going to see some of the same options: curve array, linear array, and polar array. I'm going to go ahead and drop all three of those into the canvas. I'm going to skip linear array. That's pretty self-explanatory. All right. So this is going to ask us for the base geometry, the curve to array along, and then the number of elements we want. So let's go ahead and say that, if I turn the preview off real quick here, let's go ahead and say that the base geometry that we want to array is actually a rectangle. So I'm going to draw a rectangle in Rhino and go ahead and bring that in by right-clicking and setting one geometry. All right, so now I have that here. And then I want to define a curve that I should array this along. All right. And I'll just go ahead and apply an arrowhead there so that we can array this rectangle along that curve. So I'll set one curve there by defining that curve there, and then we'll go ahead and drop in a number slider. A shortcut here is if we say we want 1 less than 25 less than 100, it will create that integer slider for us with those limits specified. So now as I increase my number of elements that will be arrayed along the curve, we'll see it update here in the Rhino viewport. Also note that the location of the geometry matters. So if it's far away from the curve, it's going to be arrayed correspondingly so, right? Or if it's on one side versus the other. Also, its rotation determines what's going to happen along that curve. All right, so I'm going to turn the preview off with that, and let's go ahead and take a look at using our polar and rectangular array. All right, now for each one of these, we're going to have a base geometry. So let's go ahead and drop in a curve parameter and draw another curve that we might want to distribute in an array transformation. So I'll draw a little control point curve inside of my rectangle here. Kind of teardrop shape. Let's go ahead and specify that here. So now I've got our curve in Grasshopper. And if we start with the polar array, geometry we want to array is this. The plane about which it's going to array is the world XY, so that's down here. And then I'm going to connect this count slider into the N input, and let's see what we get. Now, that's interesting, very floral, but again, just like the last one, it's relative to the kind of origin of transformation. Before it was the start of the curve, but here it's the plane that we've specified. So as I move my geometry away, it's going to array more with a more distributed kind of radius here. And of course, if I rotate it, it's going to update. All right. So put that back here. And let's go ahead and take a look at the same option for the rectangular array. Pretty straightforward. I'm going to use the same slider for both X and Y. Now, it has to array relative to a rectangle. So if I wanted to, if I wanted it to array based on this, I would need to set that rectangle here. All right, so now it's based on a kind of relative bounding box and instead of the default rectangle. So now I have the capacity to make my array of elements here in both the X and Y direction. All right, so that's great because it allows us out of the box to distribute geometry very quickly. We only have a couple of objects here in our definition. And let's take a look at what that might mean if we were to use the kaleidoscope and couple that with a polar array to get something a little bit more interesting. Go ahead and get rid of these two objects here. So we're starting just with our polar array. Move this guy up a little bit and increase the number. Okay, so now this is occurring about the origin here at xy being 0, 0. Let's take a look at that other transformation object we were mentioning, the kaleidoscope, which is kind of a compound transformation. It's doing multiple things at once. Instead of just arraying polar, it's doing a compound transformation. So out of this we have 23 curves. And the kaleidoscope object is asking for the base geometry, again a plane, and how many kaleidoscope segments. So let's start by dropping in our geometry into G. All right? Then let's go ahead and set a plane that is not in the same location as the origin. So I'm going to go out here, specify that plane. I'll use another slider to define how many segments I have. So now I get a kind of kaleidoscope effect based on how many segments I ask for, as well as how many I choose originally. So now we're kind of just layering up these pre-built transformations, and we get something that's pretty interesting pretty quick. And remember that this corresponds to the original location of the geometry. So if I pull it away from the origin, my kaleidoscope result is going to change. And just for fun, we can take a look at another way that we might represent this collection of objects, which doesn't really have to do with transformations, but will allow us to see the kind of complexity that's emerging from this set of transformations a little bit easier. So what I'm going to do is I'm going to divide my curve, each one of my curves that are coming out of the kaleidoscope, into a number of segments, which will give me points. I'll use another slider to define how many that's going to be, 6 points or more. Turn the preview off there. And then I'm going to couple that with a pre-built meshing algorithm called the Voronoi. If I flatten this output here, drop that in, and maybe add in another slider using our kind of shortcut method here to define the radius of our cells. Now we can kind of get a different sense of the density and relationships of all of our geometry across this compound transformation. This one's pretty dynamic and fun to work with. Be careful you don't put your slider up too far. And we can change the density both from the original radial array down to the kaleidoscope, etc. And that's pretty fun. And all that is to illustrate that very quickly with just a few objects using these transformations, we can